In this video, we're going to integrate 10 to the power of 3 secant x. So we are going to integrate this. So remember, we've already seen this identity in the previous video. If you can't remember this, then picture the unit circle in your mind. When it's at an angle of x, then this length here is tan of x. And we've already seen this. And this length here is secant of x. So you can use Pythagoras. So this here is the longest length, the hypotenuse. So hypotenuse squared would be this, and the adjacent squared would be this, and the opposite squared would be this. So if you can't remember this, if you can't remember this, then picture the unit circle in your mind. Okay, and I also require you to know that when you differentiate this, it gives you this. And again, if you can't remember how to differentiate that, then do it from scratch. What is secant of x? Secant of x is 1 over cos of x. So now you can use the quotient rule to differentiate this. Eventually, it will lead you to this. Or if you're asked to do something like differentiate cot of x, you can't remember what cot of x is. So work it out from scratch. What is cot of x? Cot of x is cos x over sine of x, and then use the quotient rule to eventually differentiate it. So I also need you to know that when you differentiate tan, it gives you this thing here. And remember, this identity here allows you to jump to convert this block into a block containing tan. Hang on. So this identity here allows you to interchange these two blocks. You see what I mean later. So let's try and integrate this. So to integrate this, have this at the back of your mind. You're trying to rewrite one thing as a derivative of another thing. So looking at this, to integrate this, your eyes should zoom into this bit here. Either try to create this, so try and get this to be this, or to be this. So as it turns out, you can break this tan block up into tan. Hang on, let me think. Tan squared x, and then tan x, and then secant x dx. So you can break this up as two blocks. You've got tan squared, and then basically extract this one block of tan, and then merge these two blocks together, and then that will then give you this thing here. So this thing here is tan x secant x, and then you can see that that if you integrate this, it will give you secant. So if you can write everything in terms of secant, then you've got something being the derivative of everything in terms of secant. Hang on, let's start again here. So to integrate this, hang on, it will make sense later on. So to integrate this, we should picture this in our minds. Write this f prime as this. So extract the tan block from here. Extract this tan block, merge these two blocks together. That will then give us this thing here. That will then give us this thing here, secant x tan x. Now, if you integrate it, it will give you this. So if we can rewrite everything here in terms of secant, then we know it will be easy to integrate. Because if you get into this form, it will be easy to integrate. So if you look back at this, we want to rewrite this in terms of secant. But at the moment is tan squared. But you see, by using this identity here, we can convert the tan squared into secant squared block. So this identity here allows us to jump back and forth between these two blocks. So the next step is, because we know that this is this bit here, we need to rewrite everything. We need to rewrite everything in terms of secant. So we got to convert this block into everything involving secant. So make use of this identity here. We need to replace this tan thing here. So take away 1 from both sides. So secant squared x, take away 1 equals tan squared x. So now we can put this into here. That will then give us this. So now you can see that this thing here is f prime, and then this thing here is all in terms of secant, as opposed to 10. So everything's in terms of secant, and then here you've got the exact derivative of secant. So get it into this form, which will be this. Now once you know it's in this form, you know it's going to be easy to integrate. So use u substitution. So let's u equals secant of x. So differentiate this. That will then give us this. Now notice that this whole block here is exactly the same as this. So we can put the u into here, and then put u into this secant here. So it becomes u squared. Take away 1 du. So this whole thing here will then become this. So now you know it's easy to integrate. This is easy to integrate. So integrate this. That will then give us this. Integrate the 1. That will then give us this. And then we said let u equal secant. So put it back into here. Put it back into here. So your final answer will be this. Okay.